Hello everyone, this is Mix K. In this video, I'm going to be going through the types of reactions notes that we went over in class. Now, in class, we did this as a pair deck. What I've done is I've set this up as an ed puzzle so that you can hear what I said like throughout class that day. So this is a good way to like help yourself get caught up. If you're watching this just as a YouTube video, that's totally fine. Just know that there's going to be occasions where I pause for people to answer on the ed puzzle. But don't stress about it if you're just watching the YouTube as a review. Okay, so let me hide this little thing. There we go. Don't think I need that. That's perfect. Okay, so for this first type of reaction, now I'm not going to give you the definition. What you're going to do is I want you to brainstorm what do all of these reactions have in common. So if you're doing the ed puzzle in a moment, the video is going to pause. And you're going to have a moment to brainstorm and write down what do you think all of these reactions have in common. And if you look at the bottom, there's a little silly example just to try and help you get your brain moving on what might be going on here. So take a look at these reactions and do a little brainstorm. Okay, so when we look at all of these reactions, you might have said a bunch of different things, and whatever you said is fine. But when we look, you're going to start to notice that we have things combining. So, this is what's known as a synthesis reaction. In a synthesis reaction, the substances combine to make one product. So, here I have two things combining to make one product. I have these two combined to make one thing. This makes one thing. This makes one thing. So, we have multiple things, two or more things combining to make one product. Now, as our little silly example, we can see if I have a plant and sun and water, eventually it'll blossom into a flower. So I have all of these things come together to make one flower, right? I made one thing in the end. Okay, so we have two or more substances, two or more reactants combined to make one product. So the way we know we have a synthesis reaction is it ends with one thing. Another good way to think about it, synthesis means to make something. So if you synthesize something, you're making a product. Okay, take another moment. This is the second type of reaction. I want you to take a look and try to brainstorm. What do these all have in common? Okay, so these are what's known as I gotta go back. Going the wrong way. Okay, there we go. That's fine. Okay, these are what's known as a decomposition reaction. Now, when we think about the word decomposition, we think about things decomposing. So here we have one reactant that breaks down into more than one product. So, for example, water can become hydrogen and oxygen. It's breaking apart. Salt can become sodium and chlorine. This snowman can become water, a hat, and a carrot. We are breaking down something into smaller pieces, into more than one product. So the way we know we have a decomposition reaction is we start with one thing. So synthesis and decomp are kind of opposites. Synthesis, we end with one thing, we make one product. Decomposition, we start with one thing, we start with one reactant. So now let's take a look at this next type. I want you to brainstorm. What do you notice these all have in common? Okay. Now, when we look at this one, this is called a single replacement reaction. And I want you to think about it kind of like if you were in a relationship and someone came in and stole your partner. Now, here's what happens you have two people together and one person that's alone, and then you end up with someone else who's alone and a new couple. In a single replacement reaction, we have an element that's by itself and it switches with part of a compound. So we have something that's single, an element, switching with something that's paired up, a compound. And when this happens, part of that compound gets kicked out, just like this guy got kicked out of his relationship. And now it's all by itself. So now it's single. So in a single replacement reaction, an element and a compound are switching. We have the element switching with one part of the compound, just like someone coming in and stealing your significant other, someone stealing your partner. Okay. Now, a good way to remember this one, you're going to have two reactants and two products. And in this one, you're going to see that there's going to be an element on both sides and a compound on both sides. And you're going to see that that element switches with the compound. So here, calcium and hydrogen switch places. So now calcium's with chlorine and hydrogen's by itself. Okay, take a look at this next type of reaction. I want you to look for a pattern and think about that single replacement one. There's something similar going on here. Okay, so this reaction is known as a double replacement reaction. In a double replacement reaction, we have two compounds this time and they swap partners. This would be like if you were dating someone and your friend was dating someone and you guys both broke up and started dating each other's exes. It's also kind of like the show Wife Swap, where two families switch moms just so they can see what their lives would be like, right? The families stay the same, but the moms switch. So, for example, in this one here, this little group, CO3, switches with chlorine. And so now chlorine's with calcium and CO3 is with hydrogen. Here, these two couples split up. Our brunettes are together here, and then we have our blonde and brunette. And then they switch, and now we got our two brunette boys over here and our two girls over here. Okay, so they swapped partners. They switched who they were dating. So in a double replacement, you have two compounds on both sides, and those compounds swap partners. All right, last time for a brainstorm. Now this one, there's some real life examples at the bottom. So I want you to take a look at this and think about what do these all have in common. This is our last type. Okay, so you're going to notice for this type, this is called a combustion reaction. Now, when we think of the word combustion, we should be thinking of things combusting, things catching on fire, because most combustion reactions have fire involved. So when we have a combustion reaction, we always start with some kind of fuel. Usually it is a carbon-based fuel, and you'll see all of these fuels have carbon and hydrogen, or carbon, hydrogen, and oxygen. In some cases, you might just have hydrogen, but these are all carbon-based fuels, and they react with oxygen gas in the air. So you guys know at this point, fire needs oxygen to burn. So our fuel plus our oxygen produces, and now here's the thing, it's going to produce the same stuff every time. Carbon dioxide, water, and energy. Carbon dioxide, water, and energy. The only difference is how much of each of these things that we make or we need to make the reaction go. Now, when we think of combustion, I want you to think about like things burning. So here my fuel is oil. Here my fuel is rocket fuel. Here my fuel is the candle, that wax. And all of these fuels react with oxygen gas and make carbon dioxide, water. And then wait a minute. I didn't write the word energy here. Sometimes it won't say energy. I put energy here to help you see that this is what part of it. But we don't always write the word energy in our balanced reactions. So we got to look for that carbon fuel, excuse me, with oxygen gas producing carbon dioxide and water. Okay, when things are burning up, they're combusting. So I want you to do a little practice. So if you take a look, we have a list of reactions. I'm going to have you pause and like either write them down and try to match each type to each one. Or if you're doing this on an Edpuzzle, you're just going to have this end of the video to answer these questions. Okay, so let's move on to the examples. Okay, so number one, okay, I want you to take a moment and try to think about what this is. So this reaction, oh, here are all the options. Sorry about that. There you go. Okay, so let's talk about what this one's going to be. This is going to be a single replacement reaction. Okay, single replacement. How do we know? Well, when we look, skipping ahead, when we look, we have an element and we have a compound. At the end, we have an element and a compound. Keep skipping ahead on me. Sorry, guys. Now, that element, Fe and Cu, are swapping places. So Fe starts being by itself, and at the end, copper's by itself and has swapped with Fe, which is now part of the compound. So in a single replacement reaction, a single element switches with part of a compound. Okay, take a minute, take a guess on what you think this one is. Okay, so this is going to be a synthesis reaction. We know it's a synthesis reaction because we have two or more reactants, what we start with, combining to make one product. So in synthesis, we always end with one thing. The stuff combines to make one product. Okay, take a look at this one. This is going to be a combustion reaction. Now, we know this because we see the same stuff every time in a combustion reaction. We have some kind of fuel that has carbon in it, reacting with oxygen gas to make carbon dioxide and water. The other thing that's produced here is energy. We're burning this fuel, we're combusting this fuel in the presence of oxygen to make carbon dioxide and water. Okay, take a look at this one. Okay, this would be a double replacement reaction. Here's how we know. We got two compounds. Now, when I look at these compounds, we can see that the elements are swapping partners. So Mg and Br are together, Cu and F are together. At the end, copper is with bromine and magnesium is with fluorine. They swapped their partner. Mg and Cu switch places. So this would be a double replacement because they're both doubled up and then they replace each other. Last one. This one's a trick. So you might want to say combustion, but here's the thing. This is not plus O2. This is just one compound. So if we have one compound splitting into two products, this would be decomposition because this substance is breaking down into these two different ones here. Okay? If it was combustion, there would be plus O2, but there's no plus here. It's just one thing breaking down, so it's decomposition. Okay, that's everything. So if you watch this as a YouTube video, I hope this was a nice review. If you did this as an ed puzzle, this is going to get you some points back if you missed the activity from class the other day. Have a wonderful day, everybody. I hope that this helped.